Hello guys and welcome back. So let's keep on going. One thing we can do here though is that we can go grab all these things and then we can click on this, and this is gonna make a subnet, and basically a network that is kind of like inside of a box. Okay, we can call this guy convert curve to space. Okay, so that way we can plug in any curve and it's gonna automatically do that for us. Okay, and that way it's easier to move things around and keep your graph clean and organized. Anyway, so now what I want to do is just get the floor, right? You could also populate something on the wall and whatever, but once you know how to do the floor, doing the wall is not that different. Anyway, so I'm gonna go ahead and say blast. Okay, but what do we blast? Well, we want to blast out everything that's not on the floor, right? So we can say blast here. We can do the points. Okay, I'm gonna say at position dot y, the y position of those guys are bigger than 0.1. Okay, oh, don't have to have the semicolon, and enter. You can see how it's basically blasting out anything that's above. Okay, now you can see our floor is flipped, so we just flip it back. So we're gonna do a reverse node to reverse it. Okay, all right. So here it's asking for a group on the blast, but we're using an expression. That's one of those things you can do. As long as you can yield a Boolean result, then it's going to be able to determine do you want to do this or not to whatever elements. Okay. All right, and we reversed it. One weird thing in this language that we're using, which is called vex, is that it doesn't have a Boolean data type. It has only two things, two base data types: integer or number, basically integer floats, those numbers, and string, and no more than that. You can have a array of stuff, right? You can have vector 1 2 3 4. That's also existing, but it's basically numbers and strings. That's all there is. This is no Boolean. Okay, which is not the end of the world. You can use 0 and 1 to represent it anyways. Anyway, enough of complaining. Let's go keep on going from here. So now for a complicated floor, what we want to do is, well, we wanted to have the floor to have varied different characteristics. For example, for this really thin ones, maybe you wanted to populate a different texture or different model, and for the ones that are bigger, maybe we want to have something different. Okay, so I kind of wanted to detect the edge based on that. Okay, and meanwhile, I kind of also wanted to be like able to say, this is just one model. How about we make it 2 rows? That would look a little bit better. Okay, so we can do like a subdivide to subdivide our model. Okay, now subdividing it its smooth way. We can tell it to not by going to the mantra one, I think. No, the last one. It's gonna be one of them. I always have to try multiple times. So yeah, this is linear, right? Linear subdivide to have more subdivisions. So now our square is like 0.5 unit for the length. Okay, anyway, I want to detect the edges. Okay, so there is a convenient grouping way to do that. We do a group, and here you can look for the check out that include by edges on shared edges. You can see how it's able to do that. Well, we're going to do that on the edge, of course. Okay, all right, let's gonna select all the edges with this group. We can say edge. Okay, and then we do a group promote to promote this group from the edge to the faces. So go there and say we're gonna convert from edges to primitive, and we're gonna promote this edge group. Okay, you can see now how we're getting all the squares that's on the edge, right? This is still too thin to have anything in the middle, but that's fine, right? If we set up a rule like this, we should follow it. Okay, cool. And then we can do a blast node and connect this group promote to the blast node and go toggle it on, and we can say, okay, we want to get the edge group. Delete it. Now you can see this is internal, so we're gonna call this guy internal. Now Control C, Control V to have a copy. And for this one, we're going to say this is going to be the edge. Now there's a convenient switch to delete non-selected. You can see now we're getting the edge. All right, pretty cool. So for the edge, I want to populate something that is kind of like a grid or whatever, right? So in that case, we need to have something built. Okay, and we can build it somewhere here or somewhere away. Just for the convenience, we can build the thing in here. So I'm gonna go create a subnetwork. This subnetwork will be an empty subnetwork. Not like this one is having something, this new one is empty. But I'm gonna double click to open it and then create a grid. Okay. Now for this grid, I'm gonna try to make it only have 2 rows but a whole lot of columns. Okay. And then I'm gonna do a convert line command. Convert line in here, and that's going to convert it into basically lines, right, like that. Okay, and then we give them thickness, which is going to be a polywire to do that. Now we got this really cool grid. Okay, right, that's also procedural modeling. We can have more or less lengths by going to the grid and tweak it, right? So yeah, that's basically the power of Houdini, right? You have everything there. You can tweak whatever happens previously to get different final result. Okay, we can create another node called null node. Null node is basically a way to indicate that this is nothing. This is just for like a reroute or whatever. Everything here will be exactly like what's happening in the connection input, right? It doesn't do anything. But you can then rename this null to out, right? That's gonna tell whatever who need to look at it will know that that's gonna be the final result. Okay. You can hit the up button to go back, the U button. Up button doesn't do that. Up button is actually the play animation thing. Let me stop and go back. U button to go up, or you can go to this folder structure and click on the object to go back. Also, I button to go in, U button to go out. Okay, and then name this guy to grid. And by the way, we haven't named anything properly yet. All those things are named in a weird, like just their own way. But you know, some of those things are just making sense. You don't have to worry about naming them. Some of them are more important, like this group, right? Group edges promote to primitive, right? To faces, right? It makes more sense, right? You can name your node properly. All right, so we have the edges, we have the grid. I want to populate this grid to every face on this edge, right? But there's a problem. First of all, the grid is too big, and also how do you populate it on the edge, right? That's another problem. So let's actually talk about that in the next video. Okay, see you next time.